This is 7th grade, lesson 6.2b. The objective: today students will review the parts of a circle and use this knowledge to find the circumference as well as the area of the circle. The standard covered is a review standard of 6EE2C. This lesson is going to help us kind of prepare for 6.3 when we're working with cylinders. Page numbers out of the hardcover book are 262 through 263, and out of the practice journal, page 144A and B. Okay, so first of all, we're going to review the different parts of a circle. So a circle is a set of all the points in a plane that are the same distance from a point called the center. So here is our center point, and a circle, all of the points, no matter where you were to touch on the outside of the circle, are the exact same distance from that center. Okay, so that's what a circle is, okay? So the radius is the distance from the center to any point on the circle. So our radius would be this part right here, from the center that touches the outside of the circle. Radius is the shorter of the two distances. One way that I try visually to remember for radius and diameter, because they're oftentimes flip-flopped, is because it's only part of the way. I could do part of an arc. And if you kind of look at that shape, it looks like an R, like if I were to do it more upright so you could see it. And I know it's kind of stretching the imagination, but that does look like a lowercase r. So that's one way that you can remember that the short distance is the radius. Okay, the diameter is the distance across the entire circle cutting through the center. So same thing, if I were to cut all the way through this from one side to the other and connect it, that's my diameter. And if you notice, if I connect between those two, it makes a capital D. So the diameter is the full distance across. Okay, our diameter, if we know the diameter, we could figure out the radius by dividing it by 2. If we know the radius, we can figure out the diameter by taking the radius times 2. So these are just some different formulas that you can use, but most often you're just going to logically think your way through. Okay, so we're going to go ahead and just practice some of the different concepts. So we've got a couple different formulas that we'll be using in our next section, and that's working with area and circumference. So before we get started on that, we kind of want to review the different parts of the circle. So here it says the diameter of the circle is 12 feet. Find the radius. So our diameter is our full distance across, and that's 12 feet, and they just want to know the radius, the half distance. So if we took 12 and divided it by 2, that would give us 6 feet for our radius. So they're going to start us off pretty easy, just working with some very basic radius and diameter concepts. Okay, the radius of a circle is 8 meters, find the diameter. So if this is 8 meters and they want the diameter, remember, is the full distance. So there's 8, there's another 8 to make that D for diameter. So 8 plus 8 would give us 16 meters. Okay, the diameter of a clock is 1 foot. So we have a clock, a circular clock. Find the radius. So sometimes they're going to give you word problems, and you just have to kind of think in terms of what it would be. So here's my clock. It says the diameter, that's the full distance, is 1 foot. They want to know just the radius. So they want to know from the middle point out. So there's a couple different ways you can do that. You can either say that it's half of a foot, or you could change this into inches, which would be 12 inches, and you could do half of that. So 12 divided by 2 would give us 6 inches. Either of these would be acceptable. Okay, so I'm going to go ahead and give you one to try. Okay, the radius of a dartboard is 9 inches. Find the diameter. So this time they're giving you the radius. They want you to find the diameter. So go ahead, pause your video and work your way through this one. You should have gotten 18 inches for this one. Okay, so that's just working with radius and diameter. Now we're going to go through and review through our formulas for finding area and circumference of a circle. So in 6th grade, a lot of you guys learned the circle song. Pi r squared sounds like area to me. When you need circumference, you just use pi d. Another way that I remember is you guys are very good at labeling area units. So whenever you would do like the area of a rectangle, you would label that whatever the units were, say they were inches, and you knew to put a little squared on it. So that's another method, is area has that squared in the formula. So that's something that you could use, but the key thing is you're going to have to memorize these two formulas. You have to know them. You have to know which one goes with what, okay? So off to the side, I do have a picture of my diameter, my radius, and my circumference. The circumference is like your perimeter of your circle, your distance around it if you had to walk around it. Okay, your area is how much space that circle is taking up. So it says find the circumference and the area of this sticker. Use 3.14 for pi. So we're going to use our formula here. And they're telling us here that the radius, this would be our radius because it's only half the distance of that circle, is 3 centimeters. So if I'm going to do the circumference equals pi, which is 3.14, times diameter. I need the diameter. So if this is 3, then that means that the whole distance is 6, so I'm going to go times 6. 3.14 times 6 gives me 18.84. The units were centimeters. And circumference, you just leave as centimeters. You do not have a squared or a cubed on it, okay? So our second formula is area of a circle. So we're going to use pi times radius squared. Pi r squared sounds like area to me. So my area equals pi, which we're going to use 3.14, times our radius, which is 3, squared. Okay, so the important thing to remember here is that you must follow orders of operation. So if I'm looking at just this equation right here, I have to follow my pendas. Parentheses, already simplified to just 3. Exponents, I have to do this part first. Okay, that becomes 9. So now I'm going to do 3.14 times 9 to get my final answer. Gives me 28.26. The label was centimeters, and this is area, so it's squared. Okay, very important that you're labeling these correctly. So that is something that I will be paying attention to as you're going through and doing your proofs, is making sure that you are labeling correctly so that I can identify if you're struggling with that. Okay. Says the diameter of a bicycle tire is 26 inches. So I'm somebody that likes to see visually what they're talking about. So here's my circle. The diameter is 26 inches. Okay. Find the circumference. So circumference equals pi times diameter. So 3.14 times diameter is 26. Okay. So 3.14 times 26 gives me 81.64. And label is inches. Okay, so now they ask us to extend on that. It says, how many rotations does the tire make to travel 95 feet? So how many times is that tire going to have to go around on that bicycle to travel the 94 feet? So here's the thing. This is asking in feet. This is in inches. So every rotation, it can cover 81.64 inches. Okay, I need to figure out how many of those are in 95 feet. So we're going to go ahead and convert our 95 feet. 95 feet equals blank inches. Okay, and some of you are going to be able to do this without setting up a proportion. I'm going to go ahead and set up proportions. So my conversion is 1 foot equals 12 inches. I'm going to cross multiply, divide. So 12 times 95 to figure out how many inches that is. 12 times 95 gives me 1,140 inches. So 1,140 inches. Okay, so I need to figure out if one rotation can do 81.64 inches, how many times would that go into this? So we're going to divide between these. So I'm going to take 1,140 and divide it by that 81.64. And when I do that, I get 13.96, or approximately 14 rotations. Okay, so that tire is going to have to spin 14 times to cover 95 feet, or approximately 95 feet. Okay, so that time they gave us a little extension activity to work with our circumference. Okay, find the circumference and area of the object. So I want you to go ahead and pause your video on this one. Find the circumference and the area. Here's your formulas that you're going to use. Make sure that you label your units correctly in the end. Okay, so here you should have gotten for this circle that had a 24-inch diameter. You should have gotten the circumference to be 75.36 and the area to be 452.16 inches squared. Okay, that's pretty much it for this lesson. Once again, it is review. It is a 6th grade skill. So just keep plugging away on those. The further you get into geometry, the more they're going to start to kind of take things away, where instead of maybe asking for the circumference, they might ask for the radius or the diameter, and just understanding that you can always plug information in to these equations. So for example, if I had circumference equals pi times diameter, let's say they wanted me to find the diameter on a circle that had a circumference of 314. I'm going to plug in the circumference. That's what I know. I know pi is 3.14. And I know that it's times d. So if they wanted to know the diameter, well, what could I do? I could go through and work to get d by itself. So clear back what we did back in chapter 1. We're going to go ahead and divide by 3.14. Divide by 3.14. So if I take 314 divided by 3.14, it should give me 100, and it does. So I end up with the diameter equaling 100 on this one. Okay, so that's just an extension activity that they may do to you, that they might introduce to you maybe on STAR or IO assessment, where they kind of tweak a little bit using that formula. So good luck with this. Key thing to remember, circumference is pi times diameter. When you need circumference, you just use pi d. And for area, it's pi r squared. Sounds like area to me.